welcome to another AQA AS chemistry video. Today I'm going to be doing a video on bond enthalpies. Let's get straight into it. So, mean bond enthalpies. Mean bond enthalpies can be used in rough calculations to predict enthalpy changes. So this is coming off the video of the Hess cycle. So these kind of coincide. This whole topic is energetics. All the topics in energetics all coincide anyway. But yeah, this is just one of the things that you need to kind of get grips of. Bond enthalpy. Bond enthalpy is the enthalpy change when 1 mole of a compound is broken in the gas phase. That's the definition, if you want to copy that down. And this varies from molecule to molecule and from bond to bond. Mean bond enthalpies. So some molecules, for example, methane, have multiple identical bonds. The energy to break the second CH bond in methane will be greater than for the first bond because the molecule will rearrange after the first bond is broken. So the CH bond enthalpy values for methane is the average of all 4 bond enthalpies. So look at the example, right? So I'm just gonna try and explain this, right? So I have this here, right? Right. So if I was to say, so to break this bond here, these are all the same bond, right? But let's say I was to break 1 CH bond, right? And that requires 401 kilojoules per mole worth of energy, right? Or the enthalpy change is 401 kilojoules per mole, and that's the enthalpy change, right? So if I wanted to break this, right? Now this is a more positively charged compound, right? So the bonding pairs are actually more closely attracted to the carbon than they are to the hydrogen, and because of that, the second CH bond is actually much stronger now. So more energy is required to actually come and break this bond. So it actually requires 413 kilojoules per mole if I wanted to break this bond, right? Now this now has it's even more positively charged, right? Let's just write another here. Like it's even more positively charged now, and you can see the trend. The electrons are even more closely attracted to the carbon now in the bonding pair, right? Break another one that requires 428 kilojoules per mole. You can now see the pattern, right? Now, if you wanted to break the next one, 439 kilojoules per mole. Now, the average. Now, this is why you have to have an average bond enthalpy, because obviously it's going through every single one. It can be kind of confusing saying the first one. If you want to be more specific, then fine. But this is what actually is happening, and that's why it's not constant. The bond enthalpy isn't constant, right? So what we do is that we take an average of all of these, divided by 4, obviously, and that we say the average bond enthalpy for a CH bond is 420.25 kilojoules per mole. And obviously, in reality, they do over a much larger range of compounds, but generally, the bond enthalpy for a CH bond is 420.25, at least for methane, for example. Well, I mean, for other compounds as well, but like this is for CH bond, 420.25 kilojoules per mole. But inaccuracies, right? So there's 2 main reasons mean bond enthalpies are inaccurate. And that's because mean bond enthalpies are only valid in the gas phase. So you might not be doing your reaction in the gas phase. So bond enthalpies depend on the particular molecule, whereas mean bond enthalpies are quoted generally. So you can't expect a perfect answer. They're good as a guide, really. And so yeah, it's the main things that they're done in the gas phase. And you might not always get to do it in the gas phase, but yeah, this is just a quick side note. I guess I'm gonna make it into a separate video, but yeah, I'm trying to rearrange my channel. That's it.